Hi everyone, this is Tim Labarge. I am the organizer MC today. We're going to give folks a couple more minutes to join us, and then we'll go ahead and get started. Thanks to those who are on so far. Hey everyone. Okay, so it is 1:02. I am going to give folks just about 1 or 2 more minutes to make sure that anyone who wants to join can, and then we will get started. All right, so we got a pretty good group on. I think we should have some more folks coming in the next couple minutes, but I think we can go ahead and get started. So, like I mentioned, my name's Tim Labarge. I'm the VP Marketing at CEI, and we've cooked up a nice bit of content for you today on artificial intelligence and machine learning. I'm going to take you through the agenda here in just a moment, and it should be great. So I did want to mention to everyone, most people have probably done this before, but there is a chat toggle on your control panel for GoToWebinar. If you hit that toggle, you should see the option to chat in. You can chat to everyone, or you can chat into the staff. So that would be myself and a couple of others. If you have questions, please put them into the chat window. We would love to to communicate and converse and discuss. So we'll have a Q&A session at the end for any questions that come up. But without further ado, we will go ahead and jump in. So here's our agenda today. So we're going to cover a handful of things, all sort of surrounding data science and AI/ML. So a little bit about why we think this is important. Really, what is it? There's a lot of misconceptions and confusion about what is data science? What's artificial intelligence? How is it different than machine learning? We're going to cover all that for you. And then we're going to talk more specifically about where you see it in kind of your everyday life today, different use cases across industries. We're going to talk then in more detail. Octavio, our data science architect, is going to take you through how it works, and then we're going to cover a kind of a live machine learning model that Octavio put together for us. So you can see on the right-hand side here, that is me at the top, Tim Lavarge. Then Mike Snell is our VP of Solutions Delivery. He is also going to be with us speaking today. And then Octavio, I already mentioned, is our resident AI/ML expert. So we will we'll push forward here. So this is a quote that we really like here, right? Which is predicting the future isn't magic, it's artificial intelligence. So really that's something that we're going to delve into a little bit more deeply here. And the idea is just, you know, that's kind of what this is all about, right? Is how do we anticipate what's coming next? How do we use the data that's available to us to consider, you know, new opportunities, new business outcomes? I mean, that's really what it is, right? Is if you have enough high quality inputs, you're able to predict what's the most likely output, right, of this given scenario. So we'll get more into that as we go. This is a quick look here at just the growing interest in data science. This is over the last 8-9 years. So this is a tool called Google Trends. And what this does is it shows us the number of searches that are appearing in Google search across these different terms, right? So they're relative to one another, but you can see starting in 2014, all 4 of these terms, machine learning, artificial intelligence, deep learning, and data science, have all grown significantly over the last 8 or 9 years, and even more so if you look at like the last 5 or 6 years. Specifically, data science and machine learning have really taken off really since looks like about 2018 or so. So this is a growing field. There's growing interest. On the next slide here, a little bit about why we think this is important. These are stats that came from a couple of studies, one being McKinsey and another from Forbes. So you can see, I'm just going to run through these really quick for you. 56% of organizations are implementing AI/ML in at least one business function, in many cases more. So that's from the McKinsey report. 76% of enterprises are prioritizing AI/ML over other IT initiatives. So more than 3/4 of enterprises, according to Forbes, are doing that. And then these last 2 points are somewhat related, right? So 67% of organizations utilizing AI/ML are reporting increases in revenue, and 79% are reporting cost decreases that are directly attributable to AI/ML implementation, whatever that may be across whatever business function. Those are the real, you know, business impact, business results that they're experiencing. So just a little bit of food for thought in terms of, hey, here's where the rest of the market is going. Here's maybe where other players in your industry are going. So with that all in mind, at this point, I am going to, as we get a little bit more into the meat of the presentation, I'm going to hand this over to Mike Snell. He will take you through some really interesting points about AI/ML that I probably do not fully understand, but he does. So much more qualified to take you through it. So Mike, I'm going to jump to the next slide here, and love if you could jump in.
Thanks, Tim. That's great. So you know, as Tim pointed out, some great statistics there. You know, folks are more interested in AI and ML, and obviously our customers and some of the customers here on the call are very interested in this. And we hear these terms all the time: data science, AI, ML, deep learning, and you know, a lot of times they're used synonymous with one another, but they do, you know, mean somewhat different things, right? So when we think of data science, this is really about, you know, taking large data sets, or, you know, often referred to as big data, and helping leverage that big data to inform, you know, human-based decision making, right? So that's the whole art of data science, and really the beginning point for most of these types of engagements is we start with data science. We can then layer on top of that AI, right? So AI is writing applications and algorithms where the computer can sort of mimic intelligent human behavior, right? They can start to understand this is an invoice, and an invoice has these fields, and these fields mean something to our backend database. Instead of a human taking a look at that and easily processing that, now we can have the computer take a look at that and process that, essentially mimicking that type of human behavior. Where it gets extra interesting is down at the bottom here, the ML and the deep learning. So machine learning is, okay, well, we've made these decisions, right? But what we want to do is we want to learn from the data over time. So we start creating models. And what we do is we train the model. So we basically tell the computer that, when you see something like this, it typically means something. And over time, the computer gets better at recognizing those patterns. It gets better at recognizing, things in the data, right? And it starts to learn from the data and then make decisions or help forecast trends. So, a good example is like, can I predict failure for a machine or a part before it breaks, right? So, like, if you're in the manufacturing business, or even if you're like something as simple as heating and cooling, like if you have to keep wine or beer or medicine chilled, as an example, how do you decide when there's probably going to be an issue and alert somebody before that issue happens? Obviously, it's very costly once the issue has happened, but if the machines can help us predict something's going wrong, then that saves a lot of money and time in the long run. And then last but not least, the deep learning is where we start to create these neural networks to create true sort of artificial intelligence, where they can combine different aspects of machine learning to make deeper decisions. And I don't know that, while the neural networks and that stuff does exist, these use cases are a little bit more rare right now, but they're definitely out there, and we're seeing it, in healthcare and other spaces as well. So that just gives you guys a high-level overview of what these terms mean and how we see them. So for most of the rest of this presentation, we're going to focus on that machine learning that we talked about. And remember, again, it's part of the data science continuum, if you will. And so what we want to do is just level set on what we mean when we talk about machine learning, right? And so you think about a traditional application is that we've got an algorithm or a computation. You put in the data, it runs it through the computation, and you get the results. In a machine learning scenario, what we try to do is the computation or algorithm happens, but it also compares that the computation with the rest of the data sets and where it's seen similar things before, and it can actually bring that experience to bear, right? So if you have a larger data set with more specific actionable items in there, then you're going to get a better performance in the end, right? So what we try to do is we still have to write that algorithm to say, okay, let's process the data, we grab the results, and then we put it through the machine learning that compares the experience, and then it provides a predictive measure, if you will, or a performance measure. And based on that performance measure, if it's high, if it's pushing towards, like, I'm very positive that you've got an issue here, then you probably should alert somebody or something to say, okay, this is what's happening in the system. If it's low, it's probably not a good indication, right? And we don't have that concern. So we're oversimplifying there, but it helps you understand a little bit about what's different between traditional software development, where we just are computing results, and machine learning development, where we're taking the results and running them through an algorithm based on experience over time. And so what does it look like to develop machine learning models, right? So these are sort of 7 machine learning processes. And if, as anybody knows who's done any sort of even business intelligence, data science, or otherwise, we all know that the hardest part is always getting the right data, right? And so gathering the data, processing the data, cleansing the data, making sure it's good data, because, as we all know, is, bad data in means bad data out, right? And so what we want to do is spend some time, making sure we're getting good data, pre-processing the data, making sure we've got what we call like data products that have been blessed by everybody and everybody's comfortable with the data that's coming out of the system. And then we want to choose a model, right? So we want to say, okay, let's pick these various data points and put them into a model. And there are a lot of commercial off-the-shelf AI ML type algorithms that are out there. That's the good news is that you don't have to develop new ML models. Instead, you have to learn how to use the ones that exist and then get in a position to both gather, pre-process your data, and then be in a position to train, test, and verify the model, right? So when we train the model, this is basically saying, okay, we've got the model here. We want to manage the various parameters of the model to say, yes, this is, we're indicating that this is a positive indicator of, either it could be fraud, if we're doing fraud detection, or it could be some, healthcare item, or it could be, failure in manufacturing, or it could be demand in inventory or something like that, like unforeseen demand or something like that, or maybe we should be changing our pricing, or, there's a lot of different ways we can leverage these models. And so once we've trained it, so the machine starts to understand what they're looking for, then we can start testing it, we can verify the results, and then over time we can tune it, and then we've got these predictions on a regular, consistent basis. And if we've done things correctly, the over time it just gets better, right? Because we feed it more data, it gets better at tuned, and it gets better at predicting outcomes and results. So we've probably all seen this, even with our social media, or with our Amazon feeds, or what have you. Anytime you're interacting and say, how do they know that I want to do these 3 things, and it's usually something like this, right? Something's been predicting this based on all your behavior. And you can, if you're a retailer, this is a great use case. But if you're in healthcare, you've got the same use case. If you're in financial services, you've got similar use cases. So we'll talk about some use cases here in the next section. Go ahead. All right. So I think one of the biggest challenges with leveraging AI ML is really identifying the use case. I think a lot of companies and a lot of organizations say, okay, yeah, we've heard about this technology. We sat, on a webinar, we read a white paper, and we like it, we love it. There's got to be a use for it, but we've got to figure out where are the use cases, how do we use it, how do we get the data, and how do we train the model, right? So you look at some of the main challenges to AI adoption, just those top 4 on the right-hand side is first of all, if the company doesn't recognize the need for AI or ML, their competitors probably do, right? So there's definitely in every industry, the ML and AI stuff is certainly a disruptive force, and so it's coming if it hasn't already hit your industry. But sometimes, the technology's there, but you have a hard time identifying, where are the use cases, right? So one of the things that you'll see at the end of our slides is spending some time with one of our AI ML specialists, where they've been there, seen that, done that before, or even just examining some of the use cases that are available to you can often provide food for thought and give you areas where you could say, okay, let's do a proof of concept around a specific use case. And then, of course, just like all the current sort of technology landscape, the lack of skilled people and hiring folks to those roles is always holding people back as well. And then, of course, data quality issues have been a problem as well. But we can certainly help solve those last 2. The piece on the right is just sort of 5 steps to identifying some use cases that might work for your team. Of course, ROI is a big thing, right? So it's pretty clear that if I'm going to spoil a large batch of medicine or wine or something like that, there's probably an ROI on that. There was another use case I remember where somebody was drilling into the ground, and if those drills break deep into the ground, it's very costly to extract them, right? But if they can predict failure before it happens, that's big. And so a lot of times you'll marry some IoT collected data with the machine learning algorithms to really be streaming and processing real time to make those types of decisions. And of course, there's ROI if you're trying to decrease costs, increase sales. All of those things drive ROI. So what we want to do is cover a few use cases by industry. And of course, if your industry isn't represented here, it doesn't mean anything other than we didn't put a slide on it. But there are, I think we put 4 or 5 industries in here and talked a little bit about their use cases, and there certainly are more. And a quick Google search will lead you to all the hundreds and hundreds of use cases that are pretty prevalent for leveraging these tools. So the one that we all sort of, I think, probably recognize the most because we all experience it is on the retail side. So specifically recommendation engines, those have existed for years, and if you look back, if you had the luxury to be in IT for as long as many of us have, those original recommendations engines were nothing more than somebody going in and saying, these things are kind of together, these things are kind of the same, right? And so they're literally clicking on those boxes. Humans were doing that. Then over time, we use tags and tag management to try and say, okay, this tagging is identifying these groups of items. And then, beyond the tagging, we started looking at customer buying behavior, like people that bought these things, kind of like these other things, right? And then now we've got all of that and more, right? So we've got now the ability to say, based on all the data, all the information, whether it's if you feed in both your sales, sort of your point of sales information, the stuff that your buying behavior previously, and if they can get access to your social media and other things like that, they will create some pretty interesting predictive algorithms. In fact, some people would say, that's when you're buying something, it's often interesting to look at what else should I be buying along these same lines, because you'll find stuff that you didn't even think of that can make your life better, or certainly increase the cost of your cart, if you will. So those are recommendation engines. Personalized offers, you're going to get those as well, right? You get those emails that say, hey, we think you'll like these 5 things, and my 5 things are different than my neighbors or my the rest of my family. It's always based on your specific item, and it's not, which again is more specific to the ML aspect and less to the sort of big categories like we used to use just demographics and things like that to say people like me probably like these things. Now we can get very specific, saying no, you will like these things, right? Because we've got these forecast engines. But beyond those 2 customer-facing retail use cases, there's things like inventory optimization or even demand generation. Things that the algorithms can pick up on that might take days or weeks for humans to figure out. That in which case, then they find themselves short of inventory, or not forecasting the right demand for the right season, right? And also things like customer churn, like why are we losing customers, or why are we losing people, or what happened? This person used to spend on average X number of dollars per month in our store. What happened, and how do we fix it, right? And so all of those are use cases for leveraging some of these ML algorithms. Insurance is another industry that's certainly if you've shopped insurance, or if you've changed insurance, or if you're looking at insurance, you've probably seen the bots that are there, and this is true in most industries. You definitely run into the bots, but you also run into a lot of prescriptive information, from the insurance companies, right? Like saying, there are things that they're notifying you of places where you might be able to save money through, various changes to your insurance, changes to the way your policies are set up. Of course, there's also for the insurance adjusters. If you look at, I talked a little bit about image recognition previously with the invoices that I was talking about, but if you look at assessors, right? Assessments used to have to drive your car or your vehicle, or even your house, or someone would have to come over and take a look at it. Now you can submit a video to a website, and you get a response pretty quickly. And a lot of that assessment is being done by the computer algorithms, right? And certainly there's still humans involved, but a lot of that stuff can assist them and provide information that that they wouldn't otherwise be aware of, right? So they can make a lot of different calculations based on that. So insurance industry, another great use of AI ML. Healthcare, I talked a little bit about, and we're going to see a demo. Octavio is going to walk us through a model that he trained to predict COVID, which is kind of interesting. But so that's that predictive care. So you look at the healthcare industry, and we do a lot of work in the healthcare space. But predictive care is always a big one, right? You've got a big data set of all the people that you're managing as a large insurance company, and you can use that data set to make decisions across your population, and you can also identify preventative care, who's at risk for what, and they've been doing, the healthcare industry's been doing this for years. They just been doing it in different ways. Now they can use all the data that's at their disposal, right, which includes your drug tests, your scans, your X-rays, things like that, to help identify things and actually make it life easier for the caregivers, right? Because now we can say, okay, based on what we're seeing here, here's what we would recommend. Where as before that was all information, that was based on your doctor's recommendation and their interpretation of the data. The algorithms can now help the doctor say, okay, this is what the computers are seeing, and the doctor can confirm it and leverage those recommendations, right? And then, of course, healthcare operations is another area, right, where we've got, how do we reduce time spent, in the process, right? From check-in all the way through discharge, right? And there's, different data would suggest, this person might need to stay extra time, and this person might be able to be released. And of course, clinical research, that scientific innovation is always on the forefront of all these types of technologies, and they certainly are using this both in diagnostics and drug discovery and care delivery. So healthcare is another great area for these tools. Manufacturing is another one, and so you see there on the left, Industry 1.0, right? This is when we had steam and water production, or leveraging steam and water power. And then Industry 2.0 is the assembly lines. Industry 3.0 is we started bringing IT systems and robotics into play. Now with what is being called Industry 4.0, we've got these smart factories, we've got IoT. And so if you've got the IoT happening, meaning that you're streaming data from all your devices that are doing a lot of the manufacturing, and the people and the floor and everything that's processing through your factory, you want to do something with that data, right? And so that data can be fed through machine learning algorithms to do lots of different things. One would be quality control, of course, and that's basically saying, inspections. I remember I had a summer job working in a factory, and my job was, quality control, and it was not a fun job. It was testing for leaks in these plastic water bottles that were going to become windshield wiper holders, right? Windshield wiper fluid holders. And now, you could run those through a quick scanner, and then they can, take pictures and identify any issues without human interaction, right? And so, one, it reduced cost, it eliminates repetitive, redundant, boring work, and it also increases the quality of the parts, right? So it makes sure that it probably finds more defective parts than you find after 8 hours a day of doing that same thing over and over. And then proactive maintenance. So this was one, what we don't want to do is we don't want the line to go down. We want to keep the manufacturing up and running where we can, and we want to make sure that we know when there's going to be downtime or an issue before it happens, right? So I've talked a lot about that, and I think that that's one of the main areas where we've seen a lot of uses of both IoT and ML to sort of predict failures before they happen, and that could be on the assembly line, but it can also be with the products when you're testing them, post-production, things like that. And last but not least is worker safety, right? So this could be issues in the workplace, hazards, safety things. Again, we're collecting a lot of data, we're scanning for a lot of information, and we want to use that data to predict where the issues might happen before they happen. So keep going. And then last but not least, on the use case front, and like I said, there's many more use cases, but we just want to cover a few just to get juices flowing, if you will, for the folks here, is the financial services markets, right? And so if if you do investing, I'm sure your investment companies already talked to you about their robo-advisor. If you look at how those robo-advisors work, that's an example of machine learning AI based on your risk tolerances, parameters, and and obviously various rules for the SEC and all that stuff. It's going to help you uncover and even make investments for you over time, right? So that's an interesting use case. And of course, fraud detection. So if you get those phone calls and say, hey, this doesn't look like you would ever do this, is it really you? Sometimes it is, right? But other times you're like, oh, thank goodness, I didn't fly to Las Vegas and buy a new set of golf clubs, right? Like that. There's lots of weird things that can happen that can be prevented through this fraud protection, and they do that by scanning large data sets and looking at behavior over time and looking at your specific instance, and then saying, okay, this looks like fraud, and they're able to do that. And then of course, just uncovering unforeseen opportunities in the market, right, or securing your banking and things like that. Again, there's great use case for this. And one use case that we didn't talk about here that I think that you start to see is even in the Microsoft Office tools, you're starting to see some AI and ML where it's helping assist you with filling out information, with typing emails, things like that. But even in software development and code, that we've got some of that happening now. In even software testing, right? So we're starting to see tests that can use algorithms to say, okay, I can find issues with this application that even test automation engineers don't typically find because they have to write very specific tests. They can write a more generic test and create a model and say, okay, here the application can go out and figure some of that stuff out. So anyways, those are just some bonus use cases, but I will pass it off to Octavio now to show us a demo of a real world scenario. Thanks.
Yeah, thanks, Mike. Appreciate you walking us through those. And what we hope to do with this next section here is, those are great examples of use cases that we are all familiar with, some or all of those, and have experienced them. Very few people, I feel like, at least me and in my circle, very few people really know what's going on kind of behind the scenes, right? What actually makes that happen? So that's why we've got Octavio here. So now we're going to transition to, kind of getting more underneath the hood, right? What's really going on here? We have one more quote that we really like here, which is, without data, you're just another person with an opinion, right? So I feel like this is coming to fruition more and more in the workplace, right? Where data and high quality data is the answer to most questions, or many questions, right? In the time of anecdotal feedback and hunches and things like that, is there's so many answers out there that we can get if we just get them, get all the data and everything aligned in the right way. So Octavio, I'm going to hand the screen over to you now, and I'm going to let you take us through some of that detail and then the model that you've created.
Okay. Can you hear me? Yes.
Yep. Sounds good. So if you share your screen, we should be able to see that.
I should share my screen.
Yep. Yeah, go ahead.
Okay. I am sharing the screen. Can you see my screen now?
Yep. Yeah, we do.
Okay. So I'm going to explain a little bit about that demo that I prepared. But before doing that, I would like to describe the process of working in an application for machine learning. So basically, you see 3 steps: the gathering data, the data preparation, and then the cleaning the data and normalization. Then you have a process to create a model. I want to make emphasis on the 3 first steps. Probably you spend using the data processing, you will spend like 80% of the time when you are working in a prototype or in a project just in the data, because data is very important for us. So without good data and good feature extraction, we cannot write good algorithms. Once you pass through these 3 steps, we usually create pipelines. Pipelines is a very common term nowadays in the cloud and data science, because basically you create like a workflow or a set of steps programmatically, which you can reuse every time you get a new batch of data. For example, you are getting data from the traffic of the network. You should install your pipeline to collect the data coming from the network, process it, and then have it in the right form, storage in let's say a S3 bucket, and then use it from there. The next steps are, once you have the data collected, so you need to create a model. So the models you use, most of the time you get libraries with models. Like traditionally we were using SVM and logistic regression and some basic algorithms, but nowadays you get a lot of libraries like in Keras for a specific convolutional networks, or also other type of algorithms. So you can reuse those algorithms and plug it in the system, setting the correct parameters, and then start training the algorithm with your data. The product of this modeling is a binary file that is a model which you can test against another set of data which was no part of the training sample. And then based on that, you evaluate how the parameters are doing of the model, and that is called validation. And once you have done that, when you are happy, you can go and test the model with the data and check the prediction capability or the efficiency of this algorithm. And at the very end, when you are happy with this testing, you are able to deploy the model to the web. That means you put a binary file with the model which includes weights of the neural network, or the binary data from the traditional model, and you create some extra code to input other set of data and having a prediction data set. So in conclusion, we will have 2 pipelines mainly, one for training the algorithm, one for training the algorithm, which includes preprocessing the data, and another one for prediction, which is to manage the algorithm and the production side. So we will see an illustration of this problem after I am done with these slides. So now here is the presentation that I select. So for a long time, I've been excited about working with X-rays and CT scans and predicting things. So the example that I select was to predict from an X-ray whether or not a patient has COVID. in countries no developed or in poor countries, there were no testing mechanisms. If I go back to the 2020 second semester, I remember the statistics of death people was infected with COVID was very high. And I was feeling very frustrated because we couldn't do anything. At that time, we didn't get a lot of X-rays because the data was collecting during this process, because I guess from March to December 2020, we didn't have a lot of data sets. Later on, some organizations of health released many data sets from COVID, like countries like Italy and some other countries with high number of cases release the data, and we were able to start proving some of these data set against the models. So we were trying to learn to detect, and this is very important. I want to make emphasis because basically a machine can emulate vision, because when you, it's like you are emulating an radiologist, X-ray specialist, which can read a picture and based on the picture get some features that are important and then say whether or not the patient has COVID. You think it maybe it's very, very simple. So in the past, the machine learning community and the Kaggle website, there were competitions. Some of the competitions were for the image recognition, and they create the AlexNet, which was detecting like 10 classes of different objects and pictures. And that was the moment when the convolutional networks, so the neural networks, were highly used. Before they were not used because were very computationally expensive. But after the GPUs, after the cloud, and after some other conditions, the machine learning speed up and deep learning start to show up. And the data set that I am using was taken from the Kaggle website, and is I took a model to discriminate between whether or not a patient has COVID. The reason I select this binary model is because I didn't want to go to more complex models, because another thing that you can do with the machine learning is you can detect specific nodules, specific cavities, specific lesions in the lungs. But I wanted to keep the model simple. So that is the reason I was doing that. But just to make sure that I have some of the data. Right now, we already have around the world 6.5 millions of people dead from COVID. Most of the cases reported until now is 602 millions and still counting. So that is why I have the motivation of using this type of data sets and try to use those to produce technology that could be useful for the humanity, mainly in poor countries, because they don't have access to testing mechanisms. Like in the US, last week I went to New York, and you see in every corner a testing site for COVID. So this is like have the economics to test all the people you want. But then many countries, they don't have this technology. So maybe with a fast and simple technique, you could screen whether or not patient has COVID, and that can improve a lot the condition of the health and the humanity. Okay, now I'm going to go to the process of how we did that. So, well, I usually get the data from DCM files that are coming from the X-ray machine. The most important thing is eliminate the personal information data. We don't want to expose data from people because that is very sensitive issue. When I work at NIH, the main point they were afraid of was this. And some radiologists, like they put the name in the picture and the radiography, so we have to delete that part before we process this data. So this is very important. Protect the people identity. Then we normalize the images because based on the countries and based on the technology, we got very different quality of X-rays. Some people just send like pictures, and we have to deal with that in order to have the same this data included in the generic data set. And in the project I was working at NIH, we were dealing with 7 different countries. So we have X-rays coming from 7 or more different machines, and we have to do all the pre-processing for that. Then we have to label the data sets. This is another point why I just got the binary classifier, because labeling the data sets is very expensive. So if we want to label like the specific area of the lesions in the lungs, you need to pay the radiologist, and that costs money. We didn't have that money, so that's why I just reuse a data set from that is available in open source. And then after that, we review the data set and we train the algorithm. That is basically what we did. Now, this is one of the neural networks that I use. So it looks very scary, but the lines of code is very small, short piece of code. Because the community of machine learning is reusing models. So when you start like creating your own convolutional network, you don't need to start from zero. Sometimes you'll go to the pseudo models and select one of the architectures, then test it against your images. And based on the results that you get, you try another network. Probably you can analyze different networks. And another thing is, like I say here, select a model that train a system with positive and negative cases, and then modify the model and test again. So you can iterate in this loop until you get good results. So basically, in this picture, you can see these layers. So these layers are like networks connections. So these are the neural networks. And basically, this the size of the thing become to the layer, the level 1 that contains the prediction. And this is very, very important. So this is the BGG 16, was used in the competition of 2014. So every year these competitions were going on. In 2014, this network did a good job, very efficient, and but the original work or the original model was the AlexNet, which practically start the highly use of convolutional networks. So this is, I am just explaining what technology I use. So if you see the first layer, sorry, okay, I'm gonna go ahead in this one. So you have an X-ray, and what the model I got is you can use pre-trained model, a ResNet, another ResNet, and then DenseNet. Then you extract the features of the 3 layers. Then you concatenate them and embed them in a generic model. You also can add extra layers to train the model, or you can use that concatenated to do the testing. And this case was another paper produced for predicting pneumonia or normal X-rays. So, but this is basically a lot of work. You need to understand the problem, and then you need to look the model that better produce results. And to do that, you need to kind of familiarize with these models available in Keras and TensorFlow or in Caffe, and then you basically are able to plug them together to get a system that predicts COVID, or predicts tuberculosis, or predicts any other thing based on how they learn. But it's like a magic. When you see the networks, then you put the pictures and how the pictures are extracting the features at every layer, and you can see how the weights that the network is computing can be reused and used with another data set and still get very good results. So now I'm gonna show the system working. The system working well. Before doing that, I would like to thank you, Siva. Siva was like a magician that was able to plug everything, like the results of the binary model, into this interface. He did it using AppRunner, which I didn't know. And with that, we have some of the test X-rays. Also, an extra data that I want to show you. We trained the model with 30,000 X-rays. So 50,000 healthy, 50,000 infected. So that's why we trained the model. And then we use 400 elements of X-rays for testing the algorithm. So, but what you can see is like, once you train the model, you produce a binary, you put it in a website. And like I say, Siva helped me to put this in the website. And then I am assuming that in a doctor office, they have an X-ray. When I click, you see it change the X-ray. And then when I click, the system that was trained say that the case is negative. Negative, that means that patient doesn't have COVID. If I go to this one, then I press the button, then it says it's a negative case. In the case of the number 1, I'm gonna check, and it's a positive COVID side. So basically, in many countries, like in Mexico, when there were like the testing for people the cost was $150 every time they went to do the testing. So they didn't want, so they went to do X-rays, and in the X-rays, then the specialists in lungs, the doctors say whether or not the lungs were damaged, and they were saying this is a highly probability case of COVID. So that is why I consider this case very important. But as you can see, there are many applications. This is for the applying computer vision or medical imaging processing. So you can train a system, and based on the system, you can detect. Now, this is in the case you have the data. We already have the data processed. But if we want to make annotations in the data, that takes very long time. So this is some of the obstacles of doing validation of the model, because you need experts doing the labeling. So there are many issues. It looks easy, but there are some problems. Problems to get the data in the right way with the high quality to do the homework. So I am done with this part. I will transfer the control to Tim.
All right. Yeah, thanks, Octavio. Appreciate you walking us through that. You know, it's a great example of, like we said, you know, there are a variety of different applications for this type of data science, this type of modeling. You know, COVID obviously is one that's probably impacted everyone who's been on this call in one way or another. So, you know, really from anything from, you know, a recommendation engine on Amazon to a fraud prevention text to, you know, predicting a positive or negative case of COVID, you know, this type of technology is really touching every industry to varying levels. So it was a great example, Octavio, and I appreciate you building that model and sharing it with us. Just a couple last points before we wrap here today. So this is our team here of experts, right? Octavio, everyone's familiar with. Derek is he's an architect. He's really good when it comes to data platforms, and then Zach is our business intelligence architect. This team is they're phenomenal at everything they do. I've seen the projects they've done. I've worked with them on various things, and it's a really impressive team. And you know, I'm going to get to a you know, like Mike mentioned earlier, an offer we've got for those folks on the call at the end here. But I would trust any of these guys to take me to the next level when it comes to data science, data platforms, BI, AI, ML, all that good stuff. So just a couple of quick sort of wrap up slides. I'm not going to spend too much time on this. For those not familiar with CEI, CEI has been around for more than 30 years. We've got locations across the U.S., particularly, you know, a lot of density in our locations on the East Coast, eastern half of the United States, Atlanta, Chicago, Cincinnati, headquartered in Pittsburgh, Virginia Beach, Washington, D.C., et cetera. You can see the list down there, but we also have global locations. We have a delivery team in Chennai, India, and then a team in Peru, and then we've got 3 locations actually in Spain: Barcelona, Madrid, Palma. We are a minority-owned, minority-founded organization. We're really active with the NMSDC and the EMSDC. We've been recognized by those organizations a handful of times for the work that we've done. It's something that we wear on our sleeves proudly, and is a big part of kind of who we are as an organization. We talked a lot about artificial intelligence, machine learning. big data, data science, all that stuff. But you can see here, we've got expertise across a really wide range of what we refer to as our practice areas. And you can see some of our primary practice areas and the technologies and tools where we are proficient. While we are ready and equipped, like we said, to help with this type of AI ML solution, we also have a variety of other capabilities and have been able to really help our clients accelerate and grow and meet their needs across these different practice areas. We are offering a free half-day session with the CEI team of experts I mentioned, really just to have an exploratory conversation, right? Determine, do you have the data? Is the data high quality enough, or how could you get that data to implement any AI ML solutions within your business to really help you enhance what you're doing, keep up with the competition, et cetera. You can see we've got Mike Snell's contact information here. If you have questions, if you have desire to get on the phone or have a type of workshop session with the team, reach out to Mike and he will get you pointed in the right direction. I can't say enough again about the team. Mike is fantastic. Octavio is fantastic, as are the other folks that I mentioned earlier. So at this point, I want to thank everyone. I know we're over by 1 minute. It's 2:01. We did have a couple of questions come in, so there will be a recording of this that we'll share with everyone. So if you have to jump off, these questions will be captured and you can watch them at your leisure. But Octavio and Mike, if you have 2 more minutes, I do have 2 questions here that wanted to bring to you guys. One is, we've talked a lot about data and the quality of data, but what we see a lot, right, and this question is around this topic, right? We see a lot of clients that have data. They know it could be insightful, they know it could be useful, but they really don't know where to start. So how do you even go about starting to understand or catalog what the data that you have access to, what the data you're already capturing, what it might be able to tell you and what it might be able to do for your organization? I don't know if that's a better one for Octavio or Mike to answer, but would appreciate if you guys could chime in.
Okay, I think first, like the data, for instance, let's assume that the retail industry, they have a website and they are collecting the sessions that the shoppers do. So with that data set, some answers can be produced by a model. For instance, predict the group that the one shopper belongs to. If you want to divide the shoppers in clusters, that could be one thing. This is another possible question, is to answer the probability of a shopper to buy a specific item. So basically, analyzing the data sets, you can try to write possible questions that you want to answer and how that is going to impact your business. This is basically the way I proceed. I don't know if I answered the question or you want to get more clarification.
No, I think you hit on a couple of good points there, Mike. I don't know, is there anything you would add to that?
Not really. I mean, other than, we do, one of the biggest things that are at the front end of a lot of these projects is data, cleansing and really sort of bringing the data in, cleansing it, and creating what we call data products, and really sort of examining, like you said, what you have, what's available to you, and how it interconnects with other bits of data. So that can often be a project unto itself. So it can be all things like, data cataloging, master data management, how do we connect other data sets with this data, all of those things. But a lot of times it really is a bit of a brute force approach where we've got to come in and dig through all that data, catalog it, and put it in. There are tools that are going to help us explore that data, but then we got to make sure that when we're bringing it in, we're not creating a bunch of duplicate data. We're not overriding other data. We got to figure out where the master data exists and how do we update those bits of data. So we do have a whole cleansing and ingestion process. And a lot of times we leverage the big data tools that are built inside of the various clouds, whether it's AWS, Azure, or Google, to help us with those scenarios. And we can certainly talk at length about that, where we've done that with other customers as well.
Perfect, great. Yeah, and I imagine that could be something, in that half-day workshop session, sort of discovery session, that's I'm sure would be a topic that was covered at length. So, all right, just one more question here, and then we will call it a day. So, AI ML doesn't always get good, for lack of a better term, good press. I feel it can be kind of polarizing if people don't fully understand how it's being used, what it's being used for. Everyone doesn't always like the algorithms that are serving up content or products or whatnot. So, are there any, in your estimation, any limitations for AI ML, or specifically, like, how do you handle any related ethical issues or biases or anything like that? Yeah, I'll open it up to you guys there.
I think the ethical considerations are very important. For instance, in a loan system, when people is asking for a loan, and if you discriminate, sometimes the model can discriminate against people with some type of income. That is a very difficult thing to evaluate. But before releasing a model, not only the accuracy of the model should be taken care of, but you also need to consider ethical issues like discrimination against some population groups, or also the bias. That you need to check that the model is not predicting based on bias. So there are some methodologies that we need to follow to make sure that the model we are deploying or the model that we are releasing doesn't have those implications. But yes, this is not a direct answer to that question, but we have the procedures to evaluate these possibilities and trying to release a model that minimize the impacts of these issues.
Got it. Great answer. And Mike, if you have anything to add, now would be the time.
Nothing, significant, but I do think that one of the things that we try to do with all this types of data is de-identify whatever data we can, right? So while the algorithms might make specific individual recommendations, the data that they're using often is a data set that's been it's not traced back to individuals, right? So I'll just add that little piece.
Yeah, understood. Great. Okay, well, I know we're a little over time, but hopefully the content was useful and informative and gave you a little bit better understanding, not only of how this technology works, but also how it can be applied, and maybe specifically how it can help you and your organization, your team. So with that, I think we'll wrap up for today. We'll have some follow-up content to come, and like I said, this is recorded, and we'll share that link for everyone in case you want to come back and review anything or you had to jump early. But again, thanks for all who joined, and thanks again to Mike and Octavio for walking us through this, and have a great rest of your day. Thanks all.
Thank you.
Thank you.